For the repeated ANOVA, first, we have several variables, right? So first, for one variable, we look at the sort management and grab all the rows that is SEM and into one data frame, and then grab all the row that is TRA into another data frame. So we separated SEM and TRA separately, and then we test the effect of training system within like different training system within SEM itself, and then we test the effect of training system in TRA itself. For each variable, we do such things. So this is the idea. So here, first we have a data. It means one column, such as GSW. And then we separate it by SEM and TRA. So first we look at SEM. In SEM, it only has two training systems. Just randomly graph. This is a fault of our dataset itself. In SEM, it only do the training system of ESPH and TM. The SEM with ESPB doesn't exist. But for TRA, they have data for each training system. Okay, so for here, SEM, we only have two training systems. So first, we look at because our goal is now to use a repeated ANOVA. And for repeated ANOVA, there is two assumptions. First, for each variable, it should follow normality. It means within this column, the data should follow normality. And Yumi already checked the normality for each column by QQ-plot, and it's very good. Here, something like this, if it is a line and not so many dots that's flying away from the line, then it's following normality. So in the report, it just have to state it like all the variable is following normality, so no problem here. I mean, this is for a repeated ANOVA. And then the second assumption is there is no outlier. So so if you look at the repeated ANOVA here, for each variable, I test if there is outlier or not. And also extreme, it means a very extreme outlier. So if there is outlier, it means maybe our result is not very reliable. And for SEM and TRA, I both do these things. So when our result is too strange, maybe we can say because it's not following, the outlier is too much, like this is a lot. So if the result is strange, we can blame here because the assumption is there is no outlier. Okay. But even though there is outlier, I still do the repeated ANOVA. So at least we have a result. So just when the result is strange, we can see this, just it. So back to here, we check the both assumption, and then first we see if there is interaction between date and the training system, not soil management and training system, okay? Because we already separated soil management by SEM and TRA. Now we're focusing on training system, but there is date here. So we see first if there is interaction between date and training system. Why I have to do this? Because like not this. Because like this, like in this date, the highest is blue. So it's like blue, orange, gray. But now this is orange, blue, gray. The highest is orange on the day 2, but the blue is the highest on day 1. And even here, the highest is gray on date 5. So in different date, training system is making different effect. Why is it like this? Because there is interaction between date and training system. So if there is something happening like this, then it's not correct that we combine all the date together and see what's the effect of different training systems, because it's actually very different from different date. And if we just combine, and it's actually bullshit. So here we check if there is interaction between date and training system. If no, then it's very simple. We just see the ANOVA result here. So like this one, but actually we're not doing this. If there is no interaction, then we can, but actually I don't have to discuss this because we're focusing on this and this, right? So let's ignore that. Let's just see this. Okay. But theoretically, if there's no interaction, then we can just simply look at the ANOVA result, just it. But if there is interaction between date and training system, we have to do pairwise test on each day to see on each date what is the effect of training system. So like in this case, it's for the SEM, it's having interaction. And then let's look at this. You can download it so it will be more clear. There is interaction, so we have to separate by date to see the result, and do ANOVA for each date separately. And here we know that on date 1, 2, 3, 5, there is significant difference from different training system. It means on these 4 dates, training system is making effect. So we can go to see the plot. Like here, 1, 2, 3, 4, there is interaction. Okay, then now we go to TRA. TRA, there is 3 training system, like what I showed before, like in the box plot. TRA is more complete. There's 3 training system in here. So it's the same. First, we check normality, and just as what you may check here, all the normality is fine. And again, we check the outlier. So for here, it states how many outliers are there. It should be 0, that we can really rely on the ANOVA result. But unfortunately, there are so many outliers. But now we're just doing this ANOVA, so I still do the ANOVA. So if the result is too strange, we can say that maybe it's because there is outlier here. Okay. So back to here. We go to ANOVA. So first, the same. We have to check if there's interaction between date and training system. If there's no interaction, then we do pairwise just by the training system itself, because date is not making difference. Like on different dates, there's same trend of training system. So it will be very simple. But if there is interaction, then I have to separate by date and do like for date 1, I'm going to do 3 ANOVA to see which pair of training system is significantly different. So it's pretty much like Tukey, but I have to do it for 5 dates. So it will be 15 ANOVA. But because it's too complicated to look at, so for these things, I just output the plot like here. So it's actually doing a pairwise test between, like in date 1, I test between blue and orange, orange and gray, blue and gray. So this is 3 tests. And then for 5 dates. So here is actually 15 pairwise tests here. So after it, we can know that on different dates, which pair of training system is different.